Hello everybody. Today we are going to see from design of database fields. Let's start reading. Attributes in ER model are known as fields in physical data model. A field is the smallest unit of data that is stored and manipulated. Fields are used in conventional files as well as in databases. It is the implementation of attributes and can be termed as smallest unit of meaningful data. Types of fields. The following are various types of fields in databases. Primary key. Any conventional file system or database stores two kinds of fields, namely descriptive fields and primary key. Descriptive fields comprise the customer names, inventory numbers, item descriptions, and so on, which are used by the application. Keys refers to the primary and foreign key that are used to find database records and relate them to one another. Keys are fundamental to the concept of relational databases because they enable tables in the database to be related with each other. A table must have a primary key, that is an attribute or combination of attributes that are guaranteed to be unique and not null. It is sometimes helpful to introduce a surrogate field to act as a key. This could be a table attribute which has no business meaning but simply added to serve as a unique identifier for each record in the table. This is sometimes referred to as plumbing. The requirements for a primary key are very hard. It must conform to the following rules. They should exist, be unique in the table. The values must not change or become null during the life of each entity instance. It must have a not null value for each instance of the entity. Surrogate keys are often required because sometimes real business data does not fulfill the requirement of a primary key. Furthermore, the surrogate key is typically a single field, not a composite key, which simplifies the database schema, particularly when the key is used in other tables as a foreign key. Most of modern RDBMS are tuned in for queries on integers, so it is divisible. So it is advisable to use this data type as a primary key. Many RDBMS provide a special serial number or sequence number of integer type, which generate a sequence of unique integers as a row is inserted into the table. Declaring a column to be of this type guarantees that a unique is generated for each inserted row. Secondary key, also known as alternate key, this is a field or collection of fields in the table which can be used as primary key in addition to the already existing primary key. Foreign keys are table attributes, the values of which are the same as those of primary keys of another table. It is often desirable to label foreign key columns explicitly, for instance by adopting a naming convention. Existence of foreign key enforces the referential integrity constraints discussed later in this unit. A referential integrity constraint references should be declared as a part of the create statement in a DBMS while creating the table. Descriptive fields, attributes that are not used as key but store business data. Rules for naming tables and fields. Names for all database elements should be unique, meaningful, short. Restrictions for naming tables. Use no acronyms or abbreviations, should be descriptive to convey meaning. Should not imply more than one subject. Restriction for naming fields. No acronyms, use abbreviation only if clear and meaningful. Should not imply more than one subject. Should be singular. While designing database fields, it is required to set the properties of the fields. name. A name is used to refer the attribute in the DBMS that uniquely labels the field. The name of the attribute in the logical data model and the name of the field in the physical data model must be same. For example, student name in a student table, data type, type of data the field is expected to store. This could be numeric, alphanumeric, etc. The data type supported by various RDBMS varies to a great extent. For example, student underscore name char25 indicates that the name of the student is of character data type. 25 indicates the maximum size of the data that can be stored in the field. The data type selected should ensure the following. It involves minimum usage of memory and represents all possible values. Supports all types of data manipulation that is expected from the business transaction. Size. It indicates the size of the database fields. Many RDBMS support sizes that are variable. For example, varchar data type in Oracle. Null or not null specifies whether the field will accept null value. Not null constraints applied in DBMS ensure that null values are not entered to the respective fields. A null value is a special value distinct from zero or blank. A null value indicates that the value is either missing or unassigned yet. We may specify that customer underscore name in a customer table to be not null. When a field is declared a primary key, DBMS automatically ensures that the field is not null. Domain. It indicates the range of values that are accepted by the fields. For example, basic underscore pay in an employee table can assume any value between the lowest basic underscore pay and highest basic underscore pay existing in the company. In such cases, the value of the field can be restricted to the one between the highest and lowest value to avoid entry of non-existing basic underscore pay. Default value. It refers to the value that is stored by default in the field. For example, ship underscore date in a invoice is most of the time same as invoice underscore data current date. When a default value is assigned to a field, it reduces a lot of data entry time and reduces the chances of error. Referential integrity. It refers to a set of rules that avoid data inconsistency and quality problems. Referential integrity ensures that the foreign key value cannot be entered unless it matches a primary key value in another table. RDBMS automatically enforces the referential integrity once the database designer identifies and implements primary and foreign key relationship. It prevents orphan records, that is, when a row containing a foreign key is created, the referential integrity constraints enforced with the RDBMS ensure that the same value also exists as a primary key in the related table. When a row is detected, it should be ensured that no foreign key in related table is the same value as primary key of the deleted row. Figure 9.3 depicts primary and foreign key for two tables, namely customer and order. So here you can see two figures, 9.3 primary key and foreign key relationships. Okay. Now customer underscore ID is the primary key in customer table and is a foreign key in order table. This referential integrity constraints ensure that the value customer underscore ID in order table must exist in the customer table. The primary key is shown in bold and the foreign key in italics. So here we come to the end. Till check your progress too. In next lecture we will complete or start with design of physical records. Till then, keep exploring.